Hello ladies and gentlemen, we're going to do 8.4, our next step with rational expressions. We're going to multiply and divide. We're going to use factoring, the dreaded F word, to reduce our rational expressions after they've been multiplied and divided. Alright, simplified form. Couple of definitions to get out of the way. The rational expression can't be reduced anymore, so it has no common terms, numerator to denominator. Okay? And then it's helpful if you remember that when we're multiplying or dividing fractions, we want to reduce or simplify before I do any additional math. All right, so for example, let me just show you a simple fraction. What if I had 3/7 multiplied by 2/9? Okay? I could, remember when you multiply a fraction, the top things multiply together and the bottom things multiply together. But I can reduce it and make the numbers smaller. So 3 goes into itself 1 time, and then 3 goes into 9 3 times. Okay? So now on the top I have 2 times 1, and on the bottom I have 7 times 3. The 2 won't go into anything on the bottom, so I'm going to have 2/21. Okay? Same thing is kind of along the same idea. I could reduce a fraction by splitting it into its factors. So for example, if I had 15/65, I could write that as 3 times 5 and then divide by, oops, that's supposed to be a 5, and then divide by 13 times 5. The 5's cancel because 5 goes into itself 1 each time. So I would have 3/13. So that's going to be the basic process that we're going to use to simplify rational expressions. All right, so let's start with an example. Oops, my paper's not all lined up. And let's simplify. And remember, simplify means that I can't reduce my fraction anymore. All right, so my first one's going to be, sorry, I can't move my paper up. All right, there we go. I'm going to have x squared plus 7x, and I'm going to divide it by x squared. So I want to reduce that. These two cannot reduce because they are separated by a plus or a minus sign. So the only way that something can reduce is if it's multiplied together. So first I'm going to factor out an x, and I'm going to get x plus 7. Notice that these two guys are multiplied together. And then I have an x squared on the bottom. Well, x goes into x squared and leaves an x. This x cannot go into this x because, again, it's separated by a plus sign. So my solution would be x plus 7 over x. And that's as simple as it gets. Okay? All right, let's do another one. Same thing, they're all going to say simplify. So if I have x squared minus 2x minus 15, and it's over x squared minus 9, I can't reduce the x squareds because they're separated by a minus sign, but I can factor the top. So my top is going to turn out to be x plus 3 and x minus 5. A negative 5 plus 3 is a negative 2, and a negative 5 times 3 is a negative 15. The bottom is a difference of 2 squares, so it's going to be x plus 3, x minus 3. These are multiplied together. The x plus 3's reduce or cancel, and I'm left with x minus 5 over x minus 3. I can't simplify those because they are separated by a minus sign, so that one is actually done. All right, I have one more example like this. Let me scoot my paper up a tad. So again, it's going to say simplify. And I'm going to have 40x plus 20 divided by 10x plus 30. Again, I can't reduce anything top to bottom because they have an addition sign, but I can factor. So I'm going to factor a 20 out on the top, and I'm going to get 2x plus 1. And then I'm going to factor a 10 out on the bottom, and I'm going to get x plus 3. Well, 10 will go into 20 2 times. I can't subtract or reduce this because I have pluses in the middle again. So then I'm going to have 2 times 2x plus 1 divided by x plus 3. we always re-expand the top, so I would distribute. We almost never do in the denominator. So if I finish this one, okay, I would have 2, and then here's my 2x plus 1, and it was divided by x plus 3. So I would redistribute on the top, and I'm going to get 4x plus 2 over x plus 3, and then that would be my answer for that one. All right. So the next thing that we're going to do is multiply rational expressions. And again, you always want to simplify before you actually start multiplying, because if I can make it a smaller expression, it's easier to manage. All right, so for my first example, we'll just jump right in. I'm going to have 5x squared over 2xy squared, and it's going to be times 6xy cubed over 10y. So I have a lot of stuff going on. And let me get a colored pen that maybe you can see. I think you can see this one, so you can still see the numbers through when I cancel things. All right, so notice, let's just start with the y's. I have 3 y's on the top that are multiplied, and I have 1, 2, 3 y's on the bottom, so those are all going to cancel, okay? On the bottom, let's do my x's next. This x and this x cancel, and they have the same power, so I'm left with an x squared on the top. 5 goes into 10 2 times. 2 goes into 6 3 times. The 3 and the 2 don't have anything in common, so I'm left with a 3x squared on the top and a 2 in the bottom. Okay? And that's a much simpler expression. All right, let's do another example. In this one, I'm going to have 8x cubed y over 2xy squared, and I'm going to multiply it by 7x to the 4th, y to the 3rd, over 4y. So again, I'm going to start reducing everything that I can. All right. Again, I'm going to start with my y's just because I have 1, 2, 3 y's on the bottom, and I have 3 y's right here, so all of those y's are going to cancel. I have 1x on the bottom, and if I put it into this one, 3 minus 1 is going to give me x squared. 2 goes into 8 4 times. 4 goes into 4 1 time. So on the top, I have left an x squared, a y, a 7, and an x to the 4th. So if I simplify that, I'm going to have 7x to the 6, because remember, if the bases are the same, I add at the top y, and I have nothing in the denominator. So then that one would be my final answer. All right, so let's do another one. Okay. So here's my example. Sorry, that's kind of a weird looking x. I have 3x minus 3x squared divided by x squared plus 4x minus 5. I'm going to multiply that by x squared plus x minus 20 divided by 3x. So to simplify this, I need to do some factoring before I can start. So I'm actually going to factor in this one, and I'm going to take out a 3x. Okay, so if I factor out a 3x, I get 1 minus x. Okay, so that's in that first expression. This can factor to be x plus 5 and x minus 4, so we are going to be doing a lot of factoring. This one can factor to be x plus 5 and x minus 1, and then the 3x stays. All right, so now let's start managing everything that's alike. The 3x and the 3x cancel. The x plus 5's cancel. Now let's talk about these two. Notice that in this one I have a negative x and a positive 1. And in this one I have a positive x and a negative 1. These two things are the exact opposite, so they actually cancel and leave a negative 1. Okay, so all I have left now on the top is the -1, and I have my x minus 4, so I'm going to have a -1 times x minus 4, which is going to be a negative x plus 4. And then that would be my final answer. So if you simplify things, they usually simplify quite a bit. All right, so now what we're going to do is we're going to talk about division of rational expressions. Division of our rational expressions. And I'm going to go back to start with regular plain old boring fractions, okay? Although we usually don't think of fractions as boring. All right, so now we're going to do division. So let's say I had a half divided by 3/4. Well, if I have two fractions divided, I multiply by the reciprocal of the denominator. The reciprocal of the denominator is 4/3. So now I can reduce it. 2 goes into 4 2 times, and my solution then is 2/3. Okay? So division is pretty easy. So now let's do that with rational expressions. All right, so here's my example. I'm going to have 7 over x plus 1 divided by x plus 2 over 2x minus 3. So the first thing that I always do before I do any reducing is flip the fractions. Okay? So I'm going to have 7 over x plus 1 multiplied by 2x minus 3 over x plus 2. And notice that I'm multiplying by the reciprocal of the denominator. Okay? This is the numerator, this is the denominator. Alrighty? So now, if you'll notice, I could try to reduce it, but nothing factors on this one, nothing factors at all, so all I have to do is redistribute across the top. I do not distribute on the bottom, because the bottom, if I leave it in its factored form, that shows me my vertical asymptotes, which we've been talking about. So then I would have 14x minus 21 over, and then I'm going to leave the denominator undistributed. Okay, that's a plus. So that would be, oops, I'm running out of room. That would be my answer. All right, so let's do another couple of examples, and then I'll get to your problems. So actually a fairly short video. We will spend a couple of days on this just practicing problems. All right, because we do have a lot of factoring to do. My next example is going to be 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. Okay. All right, first thing I'm going to do is flip my fraction, and I flip the second one. So 2x minus 10 times x squared minus 11x plus 30 over x squared minus 6x. So now what I'm going to do is I'm going to factor all of my terms. So the 7x is done. In this one down here, I can factor out a 2, and I'm going to get x minus 5. There's my times. The x squared minus 11x plus 30 is going to factor to be x minus 6 and x minus 5. And then in this expression right here, if I take out an x, I'm going to get x minus 6. All right, so now we can start reducing everything that they have in common. The x minus 5's cancel, the x minus 6's cancel, and my x cancels. So I'm left with a 7 on the top and a 2 on the bottom. So my answer is going to be 7/2. So that nasty thing actually simplified to look pretty good. All right, I have one more example. So I have 6x squared plus x minus 15 divided by 4x squared, and then I'm going to divide that by 3x squared plus 5x. And notice that even though it didn't have a denominator, we can put it over 1, and that makes our math seem better. So now I'm going to flip my second fraction. So I have 6x squared plus x minus 15 over 4x squared, and I'm going to multiply by 1 over 3x squared plus 5x. Now's when you have choices to make about how you factor. I factor with guess and test most of the time, But if that is difficult, you can always do the box. I've watched some of you factor in the box. I don't do it that way, but that's okay. You could do the AC method. So I don't care how you factor. I do guess and test. So if I factor this 6x squared plus x minus 15, my factors are going to be 3x plus 5 and 2x minus 3. And remember, it's the factors of the first thing and the last thing that subtract because I have a minus to give me the middle term. And then I'm going to have divided by 4x squared. Here's the 1. These just have an x in common, so I'm going to factor out an x. I'm going to get 3x plus 5. Well, that's pretty handy. So now if I start canceling out common things, I have the 3x plus 5's go away. I can't cancel these x's because it's separated by a minus sign. So I have this left on the top and these two things left on the bottom. And I have a 1, so I don't have to worry much about my distribution. So I'm going to have 2x minus 3 on the top and 4x to the third, because remember the power on that little guy is a 1. And then that would be my final answer. Alrighty. Let me give you your problems, and then you'll be done. And then we'll work on these in class. Okay, so all of them say simplify. Okay. All right, so the number 1, you're going to have 2x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. Your second problem is going to be x plus 5 over x cubed minus 1 times x squared plus x plus 1. And remember, you can put that over 1 to turn it into a fraction. This we've talked about earlier in the year, but I'm going to remind you of that formula. So if I have a cubed minus b cubed, that factors to be a minus b times a squared plus ab plus b squared. So remember, we did that earlier in the year. I'm just reminding you of this formula. And that is a 3, by the way. Problem number 3. You're going to have 4x over 5x minus 20 divided by x squared minus 2x over x squared minus 6x plus 8. And then I have one more problem for you, number 4, 2x squared plus 3x minus 5 over 6x divided by 2x squared plus 5x. Alrighty, there are your 4 problems. Good luck with those, and we'll go over them tomorrow in class. Have a good evening.